Hi everyone, my name is Samson Mokaya, a freelance software engineer at LD Talent. Today we'll be tackling a coding challenge from Codos, and it's called Become Immortal. I won't read the entire description, but I'll explain exactly what this challenge entails. And this challenge is about an elder who has lived for a very long time, and so they call him the Grand Patriarch, but most people refer to him as the elder. So the main part about this challenge is that the task is to determine how much time the elder receives from a ritual performed by young worshippers in a magic rectangle grid. Each worshipper should donate time based on a mystical calculation involving the XOR operation between their row and column positions. However, not every donation is perfect because of a transmission loss L. So this is the transmission loss here. So, and the system can only store time up to a certain limit. So let's now break down the challenge and work on it. But first, for an example here, as you can see, once you get these inputs, this input is for the function. And with these inputs, we get the XOR operations based on the M and N, which are the row and column. So after the transmission loss, we add the values and get 105 seconds, of which we'll apply the modulus, because these once you apply the modulus, we get with the first 100 seconds of the time will be lost, giving the answers 5. We do 105 modulo t, which is 100, you'll get 5. So without further ado, I'll just jump into the implementation. So I'll do 2 solutions today, but let's start with the first simple one. This is the solution that came to me intuitively. It's just some simple for loop. So the first thing we'll do is that we'll initialize the total time to 0. Once we've initialized the total time, we'll now loop. We want to access the grid, we'll use a for loop. So for I in range M, for J in range N, what we want to do is to get the item on cell. For instance, 1, 2, this is like IJ, the item on cell IJ. So this inner for loop helps us with that. And once we get the item, we want to get the donation. And we get the donation using the XOR operation, which is I XOR J. So this symbol here is now the bitwise operation. Once we get the donation, we want to check if this donation is greater than the transmission loss. If it's not greater than the transmission loss, we'll have to ignore it because we want to reduce, we want to minus the transmission loss so that we can get the remaining time. So if the donation is greater than L, we can now add it to the total time that is being donated to the elder. So that will be donation minus L. Oh, I think I forgot something. Plus, once you're done with that, it will look through all the items in the grid, and then we return the total time. You can't forget the modulus T. Let's run this solution. Let's wait for it to finish. And as you can see here, it took some time, but we passed most of the tests. But as you can see, my code took too long to execute. So there was a timeout, which means my solution is not quite optimal. As you can see, this is a loop inside a loop. So the time complexity of this will be of, I think it's of m times n, since we are nesting loops. And this means that when the grid becomes bigger, the time also increases. This simply because of the complexity. Because as you can see here, mm, the cell, since each of the m by n cells involve a constant amount of work, the total time complexity of this function is O of m by n, which is just a direct product of the number of rows and columns, meaning the execution time scales linearly with the size of the grid. So you want to now jump to the second solution that has a better time complexity. So this was the first solution that I had, which was just straightforward and simple. I tried to get a solution that's more optimal, but I did struggle. So after a lot of research in Google and some formulas, I arrived at a solution. And so we'll jump straight into it. So this will remain the same. We'll initialize the time. And now what we want to do, we'll use a while loop. We'll use a while loop. And one thing about this solution is that we use two bitwise operations, that is the and the XOR, to help us get what we want. So what we first do is we enter our while loop. Let me just do that, while n. So what's happening here is that the loop will continue as long as there are columns left in our grid. And inside this loop, we'll focus on reducing n progressively to 0 by isolating and processing significant blocks of the columns. So what we want to first do is apply the bitwise AND operation between n and n minus 1. So that operation will remove the lowest set bit from n, which will now help us focus on the significant subsets of the columns. So I'll just do that. Now that's the bitwise operation. So we'll store the original value of n, of small n in capital N, before modifying it, and reset x to m to prepare for processing the rows. Oh, sorry, that's supposed to be an m. Now, once we do that, we'll now nest another while loop, x here. And just like with the columns, we have nested the loop. Now for the rows, the inner loop will reduce x to 0 by removing or stripping, we use the word stripping off its lowest set bits in each iteration, which will now help us focus on the significant subsets of rows. So what we want to do next is, it's just similar to this here. Now, x. So let me just type and then explain. Now here's the bitwise operation. So what happens here is that x, this line of code here, what it will do is it removes the lowest set bit from x, shrinking our focus. So the capital X will preserve the original number of rows before this reduction. Okay. Once we've done that, we want to calculate the size of the current block by taking the differences between the new and old values. So let's do that first. Yes. Okay. x minus x n minus n. So we sort these values consistently using the smaller dimension, small s, and the larger dimension, capital S, in our calculations, like so. So we want now to calculate the donations. So we'll calculate the donation time h for the current block x, x or n. Let me just type that fast so that I can see what we are doing. So here's the XOR operation. Mhm. So we want to minus the loss as well. Okay. So what we've done here is we've calculated the donation time h for the current block x or n, and this computes the XOR of the current row and column indices, and it's adjusted for the maximum possible size of the block s minus 1 here. It's then adjusted for zero-based indexing and we reduce the transmission loss as well. We'll ensure that it doesn't go to negative using this max function here. So after this, we'll get the width of the current block of rows that can contribute to the total time, which will be constrained by the block capital S and the effective donation time. Okay, so let's do that first. Okay. So after doing this, we want to now add the total time. And to do this, we'll need to use some arithmetic operation. There's this formula for, sorry for that. So what you want to do is to calculate the total time plus equals. To calculate this, we'll need this formula. There's this arithmetic series formula, which will now help us sum all the integers from h minus w plus 1 all the way to h, each multiplied by s, which is the smaller dimension of the block, which is small s, which will now calculate the time contribution from this section. So let's type that. I had to look up the formula during my research, so I have it on the side. Just copy it. Hey, just confirm that it's correctly. Hey, once we've done that, we are now ready to return the total time. Let's not forget the last. Okay, I think everything is in order. Let's test it. Perfect. As you can see, it passes all the tests, and as you can see, the time is also very little as compared to the first solution that I had done. So this solution that I got after doing a lot of research, because initially I had to struggle with the other one because it couldn't pass all the tests. So what you see from this one is The nested structure might seem initially to imply maybe a quadratic complexity, but the bitwise reductions means that each loop halves the problem size in terms of significant contributions. So we, yeah, I think that's what makes it have a shorter time as compared to the other one, because it's efficiently skipping over non-contributing sections of the grid, because you can find some sections maybe have zeros and you don't need to take consideration of those sections. But that's it for this solution. You can attempt the tests. Toolsets, as you can see, it passes all the tests and I can submit it. And that's it for the solution. Thank you.